All right, welcome to the 51st session of the Hawaii iOS Developer Weekly Meetup. The quote of the week, let me get a full screen on this one. Quote of the week is a Steve Wozniak quote. It's funny how when you're up so late at night for so long, your mind can get into these creative places, the kind of creative places that come to you when you're halfway between asleep and awake. That was cool. So upcoming meetups. So on February 15th, O'Neill's going to be covering core data. On February 22nd, I'm going to be covering ARKit. Maybe talking about this app I'm making with Domino's in ARKit. And then on March 1st, just kind of an extended ARKit day to just talk about more ARKit stuff. So pro tip of the week. So this one, Jay, I don't know if you know this one, but to open the assistant editor in Xcode with keyboard shortcuts, you can also collapse it in Xcode. So it's Option Command Enter to open it, and then Command Enter to close. So I'll just switch over. So right in here, it's pretty awesome. So Option Command Return, and I got the side one. To collapse it, Option or just Command Return.
Yeah, I'm familiar with the Option Command because when you had to do a lot of what you call reset param, that's one of the few keyboard commands. Yeah, my old computer was having issues. Yeah.
Okay, so and then I just wanted to share last week's pro tip as well to bring up emoji view in Xcode. So you can put some emojis in your code. It's Control Command Space.
That I did not know.
Nice. So here,
why would I want to put emojis?
I think it's for like debugging. I know Ryan used it before. So you just Control Command Space and then just pop in a emoji.
What's the emoji do?
So this thing we can actually we can turn it into an enumeration, that kind of thing.
Oh, I see.
So it's pretty cool. All right, so that's the pro tips. I'm gonna head back over in. Housekeeping is Hawaii iOS Developer Meetup. We have a meetup page. I'm also a member of HICapacity. So if you want to become a member, you go to hicapacity.org/membership. The bathroom in the iLab is to the left. And we have a Slack channel. So just give me your email if you need to be added to it. So the agenda for tonight is RX Swift. We're going to do introductions. There's a ton of write-up. We're probably going to go kind of slow tonight. Just cover like as much of this primer as possible. So for introductions, Che, you want to go first?
Of course.
All right.
Okay. I'm been a developer for about more than 6 years, 6 or 7 years, and been currently working on a project called GoCube. It's almost done. Took a while because there were a lot of changes, updates, and we're going to be putting up test flight hopefully end of February, mid to end of February. Things go well, and I'm interested in music and learning machine learning and advanced mathematics.
Nice. Thanks for being here, Jay. Sure. I'm David. I'm from Hawaii. I'm currently working on a procedurally generated car game. I'm not really stuck on anything right now. I want to learn more about RX Swift, so that's why we're talking about that tonight. Recent win for me has been, I guess, completing the RX Swift programming challenge in the write-up. And besides programming computers, to science, I guess, right now, just broadly science. Okay, so that's the introduction. So, what do you say, Jay? Can we go into it?
Yes.
All right. So I'm just going to get up here and just move this so we can full screen the screen share. There we go. All right. So first, I'll show what we're creating. So I'm going to head over to Xcode, and I've got it up already. So I'm just going to run it. Launching. Just waiting for it to launch in the simulator. Attaching. Right. All right, so this is the app right here. It's just a label, and it has a button on the bottom. So if you tap it, it starts counting up. So that's all we're doing. It looks really simple, but the way that we're going to build it is going to use RX.
Right.
And what the most important part we're keeping to is we want to remove state. So we're using RX Swift to not have any state in the program. So close out the simulator, and I'll head over to the web page with the information on it. So I'm just going to put this one. I want to go to cases 1. And we're only going to do, today, we're only going to do 1 through 4, because 5 just goes way out in the weeds. It kind of doesn't apply. So we'll start here. So basically this is a write-up, and I took kind of the cool parts out of it, so rather than read through this, I kind of have a write-up, and feel free to ask questions if you have any. So tonight's discussion topic is creating a reactive app with RxSwift. So this is a write-up by Casey Liss, and he says, Rx has made my code better. This is him after he's been using Reactive Swift for, or RxSwift for about a year. Rx has made my code better in almost every measure. I'm really glad to have been introduced to it, and I can't really imagine writing code any other way. Even though it's a steep learning curve, it requires rewiring your brain to think about problems differently. The juice is well worth the squeeze. So a one-sentence review of reactive programming. It's modeling a system using a series of composable streams of data and eliminating stored state whenever possible. And then I'll just finish reading just this top one. So having worked in RxSwift since February, I've come to really love it. It's taken me a long time to unlearn all the ways I've traditionally thought about writing code. I'm still struggling from time to time to truly understand the right reactive way to approach the problem. So we'll get back to this later. Let's go back over to the primer. So we're just building this app right here. And I demoed it already. So how about you say, how about let's just go through and let's just build this the regular way. And then we can compare them. So I'm going to switch back over and I'll create a new project. So I'm going to Shift Command N. Just creating a single view app, and we'll call it RxSwift 002. I'm going to go next on it, save it in here. And then, so I'm seeing here, let's head over to the storyboard first. Seeing we just want to have an app with, find this page, move it to the right side. So it's just what, a label and a button, right? So minimize this one, head back over here, and we're just going to get a label and a button. So I'm just going to pull this up a bit, and I'm going to look for a label. Drag it over, and put it right in the middle. I'll add the constraints, so full screen this. Zoom in a bit so you can see it. And add the constraints to actually just these horizontal and vertical constraints to get it right in the middle. And then we just want to do a button. So we add a button here. I'll scroll down a bit, and I'm just going to conform to getting this one right in the middle. The horizontal container, and then constrain the size of it. And then I'm going to put it just 30 works from the bottom. So we're good. So it's set. So we've got those two things. What do you think the next move is? Okay. So I'll connect it to the outlet next. So I've got the code right here. I'm going to connect it up. So I'll say label, and that's going to be an outlet, and then we're going to have a button. So control click over, bring in the button, name the button, just return. So we've got those two outlets now. So the next thing we need to do is we'll look back at this, and this just says you have tapped the button. So I'm going to initialize it with 0 times. So let's say this one is going to be, where is this? There we go. You have tapped this button 0 times. At the end times. So now we'll be running. I want to run a simulator. Run this one. So go down here and running it. So we should see something like this. I should actually update the button. So I'll put tap me on this one. Tap me, enter. And then I'm using the trick that O'Neill taught me. So with this updating the button, get the dot 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 command equals, take care of it. And then I'm also going to use another tip one that showed me. And update the cell with this button. I should have updated it.
Do it manually.
Right. So I'll do this, and then I'll update constraints. There we go. So now that should work, and I'm going to run it one more time. And all of that basically to get just something you can tap and it updates the. What did we lose here? We lost this.
Yeah, where's the label?
Shoot. You have tapped this button 0 times. Okay, we got that. So we're running it. Going back here. And then we just want to update this, right? So we probably have to have a count, right?
Yes.
Okay. So this is running fine. tapping it does nothing. So we said we want to have a count. We'll head over here. And so this is actually going to be the state that we have. So count is going to be int, and we'll initialize it to 0.
Right.
So inside of the button action, set of button action, drag it over and pressed with an action.
Yep.
And connecting it up. And then now here, I just want to update the count. So if the button is pressed, I want to say count equals.
Hey,
how's it going?
Yeah,
Yes.
just like it.
Count plus 1. What was your name?
I'm Andrew.
Andrew, David, nice to meet you.
David, nice to meet you.
Hi. Jake.
Jake, nice to meet you.
So we're just starting in. So do you have experience with Swift?
Yeah, so
Okay.
I was hoping to get back into it because when I was I'm 1 year out of college from Indiana, and I used to do a lot of like iOS engineering, but I kind of got out of it.
Right on, yeah. Cool.
Yeah.
So we're just creating it the regular way right now, and then after we get it set up this way, we're going to be transforming it into using RX, so losing state
Okay.
along the way. So we're just about finishing this one up. So after we update the count, we want to update the label as well. So I'm going to say label.text equals, and then we have our string interpolation slash. Now I just want to do the count in here, but I also want to do the you have tapped the button.
Exactly.
You have tapped whatever this button blank times. So I'm going to cut this one out, paste it right in here, and then run it. And it should build and it should work, and we should see that number update in the label. Alright, so there. That looks a lot like what we're doing here. Same thing, right? Any questions on how we got it? Pretty straightforward. Okay, so we finished this up. In part 2, here we're going to start examining the code. So I'm going to kind of slow it down a bit as we go into part 2, because all of this stuff matters. So I'll close out this one. Let's actually close out the simulator. Head back over the code, and we won't really have to touch any more of the main storyboard. So I'm just going to close that side. And I'm going to use the keyboard shortcut we talked about earlier to close this side. So it's going to be Control Command Return. Or actually, just Command Return. There we go. So now we're in here. So we'll head back over to the primer and start with number 2. So in order to learn about ArcSwift, I wanted to come up with a completely contrived demo. We've done this already. We are really keeping it narrowly focused on this just so we can really kind of talk through and really understand what's happening here. So I'll scroll past this. This is what we accomplished so far. And this is basically how we have things set up. So we've imported UIKit for the buttons and the label. We've set up the outlet, and we also have a count going. And then we just have a button that you press, it updates the counter, and it updates the text labels. It's not too much to it, so that's it. So next step we're going to do is converting it to RX. So I'm going to, if you guys have any questions, please just shout them out right now. I've done this tutorial 3 times, so I don't think I'll get lost in it. So marble diagram basically is saying that this is one way of saying that this line is a stream of actions that are happening. It goes from left to right. So these different colors just indicate that whatever is being affected here, let's say the button, it's going to get one action, then it's going to do another action like a press, and then 3. And then this line just means that this is the end of the stream of actions. So with RxSwift, we're just creating, making variables observable so that we can take care of seeing these actions come in. And then once we have that stream set up on a button, we can do higher order functions like mapping, and transform it and do things to it. And the great thing, what we're going to do through tonight is we're going to be transforming it once, and then we're actually going to be doing an accumulator, and then we are actually going to be like subscribing to the events, and then we're also going to be working with disposable bags to like throw away some code.
Basically, like
Get rid of the reference.
basically with observables, similar to key value observable.
Yeah.
Yeah, it's similar because it.
Any questions so far?
Is there a Wi-Fi password I can hop onto?
Do you have a UH?
No, I'm not
Shoot.
so I can't.
Oh,
Good.
Wi-Fi.
All right. Are you?
Yeah. I
Oh,
love
okay,
that.
okay.
Yeah. I love.
Thanks.
Sure. Okay, so no questions. I'm gonna keep going through. So I think this one in italics is something to note because it's pretty important. So as an aside, you'll notice in some marble diagrams, the arrows aren't arrows at all. but actually lines, will end with either a pipe symbol or an X. A pipe represents a stream that has been completed. These streams have declared that they will never signal again. An X represents an error. Streams that are error do not continue to signal events after the error. So basically what we said before, tap, 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 it's going to the right, and then it equates to the first tap, second tap, third tap. So clearly the place we start with is with the UI button that's being tapped. In order to get access to that button programmatically, we'll need to add it to our view controller. I've done so and called it button. So before we get into this, we need to actually import RxCocoa and RxSwift. So we'll be using CocoaPods to do this. And has anyone not used CocoaPods before for dependencies? Okay, I'm just going to go through it then. I'll be adding it to this one. So I'm going to go into my command line.
I think I may have to update my CocoaPods.
Oh man, good luck. It's going to take a long time.
Really?
Yeah. So I'm heading over to Swift 2, or this project right here that we have, and then I'm going to do a pod in it. And then I'm going to see it in there, so I have the pod file now. I'm going to head back over to Xcode in the project, and now I should see, I'm going to close this one out. To update in here though. So let me keep this one in here, and then I'll do a pod init, and then I'm going to do a pod install without anything inside of it, just to get the pod file done and the XC workspace. So that's done. Head back in here, I'm going to close it, and then I'm going to head over to the Finder, and then I'm going to bring up the code. So into the iOS for the RxSwift 2. Here's the pod file that I want, and I'm just going to open it up with Sublime, so I can update it with the dependencies. So here we are. I have it already written out. All we're going to be doing is importing RxSwift and RxCocoa, and then, so like I said earlier when I mentioned what we'd be covering in this primer today, is we're only going to be covering 1, 2, 3, and 4. I feel that 5 is out of the scope of what really needs to be discussed tonight, so we won't be doing any testing. So we're only going to be importing RxSwift and RxCocoa. I have this written out already in a different project, so I'm just going to grab that. Let me know if I'm going too fast too, please. RxSwift 1. RxSwift 1, just waiting for it to come up. Just waiting for it. Oh, here it is. Okay, just looking at my pod file. Here's the two that I want to pull in. So just RxSwift, RxCocoa. I'm copying this. I'm just going to keep this on minimized because I might need to go back to it. I'm going to paste it in, save it, and then I can close this one down, head back over to the command line. And we're still in here, so we've got the pod file updated with RxSwift and RxCocoa, so I'm going to do a pod install one more time, and we'll watch it install. So it's installing RxCocoa and RxSwift, great. So now again, when you do CocoaPods, make sure you don't open up the Xcode project file, make sure you open up the XC workspace. So I'm going to just do that from here. Do an ls, I see it in here, so I'm going to do open rxswift2.xc workspace. There we go. So we've got it open now. I'm going to change the simulator just to make sure that I'm not opening it up on my phone, which will take forever. I'm going to open up this guy, go back to the view controller. So now that we have RxSwift and RxCocoa installed, I'm going to head back over and we can start updating this. So we've got the button in here, it's already hooked up. So head back down to here. And just kind of a refresher of the code that we have, here's what it looks like. Closing down the side so you can see it. So we've got the button already, so we'll just leave it right there. And next, what it says is we need to import RxSwift and RxCocoa. So I'm going to copy this, head back over to the project, and paste it in at the top. Then I'm going to save and build. Also, please let me know if you guys need me to talk louder or anything. So I'm building, it's bringing in the project, it's building RxSwift. I'm just going to leave that going because it's fine, and we're going to scroll down. So I'm going to read this out a bit because I think it's helpful. RxCocoa. RxSwift is a foundation. It works for any sort of Swift and is not specific to user interfaces, network calls, nor anything else. RxCocoa is, in short, UI kit wrapped in Rx. For work done on user interfaces, you'll need to import both of these. Most UI kit controls will have reactive extensions, such as sliders, such as buttons, these kind of things. And in general, they'll be exposed to developers' need Rx property. So to get to the string that represents taps of a button in our view controller, we need to use button.rx.tap. That is such a clean way of using it. I love that. I'm going to copy it, bring it in here. We're just going to slowly be updating this one. So how about, instead of having the action of the button pressed, we're going to access the button itself. I'm also going to delete this did receive memory warning because we're just not going to need it in this project. So right in here inside of view did load, I can do this button.rx.tap. And after we have that, we need to make it an observable. So button.rx.tap is a variable that returns a control event. A control event is a special kind of something else, an observable. Every time I've said stream, what I'm really saying is observable. So like he said before in this write-up, stream is basically actions that are happening on a UI element, and you're observing that stream that's coming through. So the stream is actually an observable. Observables are the way streams are represented in RX. You can perform many operations on observables. That's what the entire RX Marble site is for. I'll leave that to you to look into. Most things that you work with in RX are related to or can be converted to an observable. In fact, most higher order types like control event can be converted to observables by using .as observable. At the end of the day, just remember that an observable is simply a representation of a stream of events over time. So, next we come to subscriptions. Generally speaking, the last operation you want to perform on an observable on a stream is to take action based on the stream signaling. In our case, how do we take action every time the button's tapped? We will subscribe to that observable. This allows us to provide a closure where we run whatever code we need. So our code will now look like this. So I'm just going to copy this out. We've got the reference to our button. So I'm just going to paste it in here. So now we're saying self with the number variable button, or the outlet button. We've got it, the RX opening up to the tap feature, and we're subscribing to it. So right in here, if I just do a print statement, I'll just say button pressed, I can actually just kind of disable all this stuff. So we're not even going to be calling this one anymore. We don't need it anymore, but I'm just going to leave it, I suppose. Actually, you know what, I'm going to take it out, but I want to keep these in. I'll just comment it out for now. Okay, so we've got the action. I'm just concerned that commenting that out and not removing the reference in the storyboard might mess things up, so I'm just going to remove that, just because we got it set up in here. So removing the button tap, deleting that, closing this one out, and now I'm running it. And I'll bring up the console in the bottom so we can see it. And we just have it running with RX, so anytime we click on that button, we don't have to write any kind of action, it's just set there. And anytime we click on the button, it's going to show button pressed. And that's pretty nuts that it's just within the code. So I'll move this over a bit so we can see it. It's going to come up right here. Tap, boom. No need for an action, an IB action. It's pretty great. But we're going to
how is it doing that?
So it's doing that with the the RX Swift framework. So let's go back to the code that we have. So on the view controller, what we did here, so this is just a basic button, right? It's just a regular IB outlet that we hooked up.
Okay.
And then now we're referring to, within the view did load, we can put this anywhere, but we're just setting it up so that this button with the React extension on it responds to a tap gesture.
Oh, that's awesome.
Yeah, it saves a lot of time. So what we did is we subscribed to any of the taps that happen to the button, and now we can perform an action on it within a closure. Pretty awesome. So we'll keep going with that. So saving that, we proved that it works with running it. So let's move on. Unless anyone has any questions. Okay. All right, so what do we do inside the closure when observable signals? So wiring it up. So we kind of did something just to print, but he wants us to update it so that now we want to actually call the tap function on button tap. So I'm copying this and putting it in here now. So now this will actually call this function on button tap with the button that's being pressed. Saving that, moving on. Since we don't need on button tap sender to be in an IB action anymore, we can get rid of the sender parameter, which cleans up things nicely. So I head back over and I can just remove the sender. So it's just a nice parameterless function. So that takes care of it. And next we're on to disposables. I'm going to leave, so you notice this error right in here, I'm just going to leave it for now. It will go away once we do more updates. Disposables. In principle, we can build and run this right now and things should work. However, if we do, we'll see a build warning. So we've got the subscribe on next, and the result of the call to subscribe on completed, on disposed is unused. So it wants us to dispose of this. Basically, it wants us to dispose of these, what's the word? The observables that are hooked up to the button at this point. And the way that you do that is you use a dispose bag. The great thing about a dispose bag is that you can pile in a bunch of observables, and then when you dispose of it, it disposes of all of those observables for you.
Instead of having to do it manually.
Yeah,
each
one
that
by one,
gets
exactly.
really annoying, and you'll mess up.
Right, so what we're going to do is we're going to create this private variable, put them up at the top. So we got the dispose bag, and all we're going to do at the bottom of it, since this is all connected in, I think it goes, okay, it goes outside. So we'll go right in here, and we do a dot, and then dispose by, and then dispose bag, which is the variable we just created up there. Building. Still, it failed because we are calling this function right in here. So, and then we'll use it on the subscribe call. Okay, so we've done that. Just want to make sure I have this lined up correctly. And I'm going to get a bit more spacing here. I realize the font might be a bit small too, so make this bigger. Okay, so we go down here. All right, so don't let this put you off. There's really nothing to managing resources. Having a way to reliably dispose of all active observables comes in very handy from time to time. After a year of doing RxSwift, I've never had to think about disposable outside of dropping things in a dispose bag. Generally speaking, each class struct that is doing subscribing gets one shared dispose bag, and all subscriptions get added to it. Next up, we're going to talk about debugging. With the code we have above, it will run and it will work. However, what if we want to debug what's happening within an observable chain? So this is kind of saying, because we're chaining up things, like we have our subscribe, and then we can dispose of it, we can just toss in a debug at any of these steps to really find out what's happening here with this specific observable. So naturally, we can place a breakpoint within a closure such as the one we're providing to subscribe. Sometimes, though, you want to see flow, even in places where we don't have a closure to interrupt. Luckily, HICapacity provides an easy way to handle this with debug. Let's change our chain to include a call to debug. So we're just putting a debug at the top, changing up to here, and so I believe it was before the subscribe, so I'm putting it up here. Still seeing the on next error, and I believe I just have one too many in here. Subscribe. Should I copy this? Should be good to go. Building. Still got the on next. I know I ran into this issue before. I'm not fixing this myself. And I believe, actually I don't want to waste time, so I'm going to grab it from what I have here. Over. Where was it? Okay, I'm just going to do it on this side. Subscribe on next itself. Oh. This is right. Let me just set this real quick. I think this is an older version, so I need to just update this. I think it's this time. Subscribe. Okay. Go, and I'll unwrap itself. If not, self. So this was written in 2016, so there might be a few differences. Should take care of it. Okay. Oh, bad. Okay, so So that should be good, and we'll see the debug. There we go. So we're running it now. So we should just see that the debug turning up button tap. So right here it showed us our debug. We haven't tapped anything, but it got called and viewed the load. So right when the subscribe happened, we've subscribed to this. So head back over. Now we got that running. Now we'll do click 3 times and we should see this event next as well. So head back over to the app and we see event next. So we're good to go. Alright, so next up, saving that, heading back over. Alright, moving down here. I'm going to just move over a lot of this. So next steps. Now we've dipped our toe into wiring a procedural interface with Rx. So far, we haven't really reaped any benefits. We're simply calling into our old code differently. Having started here, we're now one step closer to having proper Rx implementation. In the next post, which will be primer part 3, we're only going till 4. In the next post, we'll start to explore a more Rx-y way of going about implementing our view controller. This will include the real coup de grace, getting rid of var count. So we will be pursuing a stateless button press. Exciting stuff. So we've recapped. We created our outlet, the label and the button. We have the dispose bag and a count. We're going to be removing the count at some point, so we don't have save state anymore. We created in the view to load the reactive Swift button. We have a debug happening, and then we also get notifications now that it's being subscribed to, when it's tapped and all that kind of stuff. It gets sent to the dispose bag where it's the memory is being released. And then we also have a private function that's actually doing the updating.
Subscribe. Yeah, okay.
So we will be going further into like more of these, just these specific functions next. So this is fine, but it's already obvious that something is redundant. So a quick win is a first step. Let's get rid of the useless on button tap. We can fold that into the subscribe, which I think we've already done. No, we haven't. No. Oh, we haven't. We actually just didn't put it in there. So I'm just going to grab this code right here and copying it, heading over here. So now we don't even have to do the button tap anymore. So we're just going to paste this in here. And delete this stuff, building. So now we can, here's where we meant to take it out. So I'm just going to delete that. And now we have a build. But I have these 2 selves, so I just need to replace them with the unwrapped self in here. And then building again. Got this in here. So count. I need to do this unwrapped self in here. Building, and then I'm going to run it. Right, yeah.
Okay. In this case, the code is so simple that you could remove that function.
Yes.
If it's more complicated, I'd probably use a function.
Right.
So it really depends.
So what we're going to do here, and the next step is we're going to kind of extract this into its own higher order function with a scan function. So save this. I'll head back over to the write-up. So the quick win, we got rid of the useless on tap button, and we have folded it in like we did right here. So it's right here, and there's no longer a button tapped function that we're calling. So I head back down. It's definitely an improvement, but there's still many more things we can do in order to make things better. Scan. In the first part of this series, I said Rx brings a bunch of tools to the table. Some are the ones we already know, some are totally new. Once you get to know these tools, it's easy to reason about what is being done to the stream. So back to streams. Today we're going to add a new tool to our toolbox called scan. The scan function is summarized in the official Rx site as apply a function to each item emitted by an observable, so like a tap, sequentially, and emit each successive value. What? In the documentation, there's an interesting tidbit that sounds vaguely familiar. This sort of operator is sometimes called an accumulator in other contexts. This is still confusing though. Let's see if we can make sense of this by checking out the marble diagram. So like we said earlier, each click is one of these coming in, right? And what we can say with each of these is with a scan function, each click coming in, we can have it add to the previous one. So 1, 2, 3, 4, 5 is going to be added, and it's going to come up with 6, right? Or I'm sorry, it's going to be the accumulation of all of these, so it's going to be 15. So now the accumulator seems to make sense. Anyone have any questions?
Nope.
Okay. Now the accumulator seems to make sense. With each new input, 1, 2, 3, 4, 5, we seem to be adding that value to the sum of all previous values. Suddenly, accumulator makes more sense. In fact, this looks very similar to vanilla Swift's reduce function. Using scan. So how do we actually use scan? Looking at the way it's declared gives us a hint. So this is the method signature right here.
Similar to reduce.
So it's going to be actually returning an Rx Swift observable, right, with a seed of a number. So we can throw in a number, and it accumulates it. So it looks like we provide a seed value, then there's a closure to perform whatever accumulation we make or we'd like. What if we seed the scan with 0 rather than overriding that we have? Let's do this separately. So this is just to prove that it's returning an observable. So we're just copying it. We're going to paste it in. Let's just put it in the view did load. And we're just going to build it. That's all we care about right now because we want this warning to show us actually, what is this thing returning? So we can hover over, hold Option, click for the quick help, and we see that it's actually returning an observable int, right? So it's returning an observable int type, right? And that's what we're going to be accumulating. So with that said, let me know if I'm going too fast to our first questions. So I just covered all of this. Awesome, we've now got an observable int, which theoretically means we have an observable that will signal the current tap count every time the button's tapped. It's pretty perfect for what we're doing by counting taps. So I also found that these italicized asides are extremely helpful, so I'm going to read it out. Aside, I find it's often useful to break one observable chain up, as we've done above, and leverage Swift's type inference to ensure that I'm operating on types I expect. In this contrived example, it's pretty obvious what's happening, but in more complex cases, especially when we begin combining streams, things get hairy quickly. So another cool thing, we're not going to be covering it today, but in combining streams, you could actually take in the streams that are happening on multiple UI elements, which is pretty awesome, and then you can do logic to see what you want to do based on what's coming through. So finishing up this italicized part, additionally the Swift compiler's type inference often gets tripped up once you get to combining many different streams and mutating them. One easy way to cheat and get back into the compiler's good graces is to split up these calls and, if necessary, annotate the types as required.
In other words, make it explicit when it's needed.
Exactly.
Because even on my app, there are times where I can't use the type inference because I'm using two different types like float and double.
Right, yeah.
When you're dealing with that,
yeah,
sometimes
you gotta say it.
Yeah,
exactly.
And with my grid app, I had to be very explicit because I need to use an unsigned int instead of a regular int.
Yep.
Otherwise, you know what happens when you do maximum errors. There are times when you have to be explicit with your types, and sometimes you can basically get away with type inference, but there are some cases where you have to be explicit with the types, especially when you're doing numerical calculations between float and double.
Right.
That can trip you up many times over. I've done that too many times.
All right, any other questions or comments? Yeah. Okay. So wiring it up, let's dump our temporary variable O and use this scan function. Further, let's add a couple debugs for good measure. Our new chain looks like this. So rather than just copy this, I'm going to kind of just go through. So and then we got a debug after the scan. So I'll put in the 2 debugs, push this one down so we can see more. So you get a debug up here, and then there's a debug after it. So they want us to move our scan from here, and just drop it right in here. So I'm going to use the highlight and then the Control-I to do the automatic indenting. It doesn't work on this one, fortunately, so I'm just going to tab it in. Tab it in right here. And then I'm also going to just put in this last curly brace because we need it.
Yeah, you need it.
So now this is no longer necessary because that was just to test what is returning. Okay. So I deleted that. I'm saving and I'm building. So now we got the scan, and we got the debug after the scan. So what this scan is doing, does anyone want to just guess what the scan is doing? From what we just discussed earlier?
Scan, just the name.
Right. So
you're scanning each object in the stream and seeing what's in it.
Right. So we got the scan and we got the seed of 0 now.
Right.
So we know we're returning an observable int,
right,
or of int type.
Right.
So now what this is going to do is it's going to print back the value plus 1 or prior value. So it's accumulating.
Yeah. Basically, it's like in a way similar to the reduce function.
Yes. Exactly.
Very similar for the sequences. Because I noticed with the reduce you need to have an initial value and your adder, your result type.
Right.
Similar, very
Right.
similar.
Right.
And the fact that I see how a reactor works. It's just basically you're chaining these functions.
Exactly.
It's like mad filter.
Exactly. So it's really elegant.
Yeah, it's pretty much functional programming
Mm-hmm.
with a slight twist to it.
Right. Exactly. And it's really, I mean, because everything is being held and retained within the button itself, which is the most interesting part. It's like each UI element contains its own count, and it'll keep it there, so we don't have to keep state outside of it. Okay, so I'll keep going. So notice something important here. We now have two calls to debug. Our existing one that hangs off of button.rx.tap, and a new one that hangs off the scan. Let's run the app tap 3 times, then look at both the screen and the output. I drop an animated GIF of the screen behavior, but it looks the same way as it did, which is a victory. Looking at the console output, I've added some new lines for clarity, but otherwise haven't changed a thing. So you'll notice now, when we run it, make sure I bring up Xcode, and I'll make sure, I'm actually going to stop it with Command period, and I just want to make sure it's running from this, what we've done so far. So Command R to run it. And we've got our 2 debugs now, so I'll bring up the console, and we'll see that we have the 2 subscribe, right? So we've got our after scan and our button tap. So the next thing we want to do is if we do a tap, now we have the observable.
I see.
And then we also have the observable int. So we keep tapping it. What do you guys think is going to happen?
2.
Yeah.
And then the way you designed it is 3, 4, 5, 6.
Right. So now it's accumulating on its own.
Yep.
So now that we have that going, I don't want to jump ahead in the write-up, so I'll just keep with this. So that's going. It's pretty great. Notice not only are there 2 entries per event on the button.rx.tap observable, one for each debug call, but they are showing different payloads. The first is a void, we discussed last time. The second is the int that comes out of the scan. So this is the int that's coming out of the scan. It's pretty neat. It's important to remember that debug shows you the state of the stream at the point in the composition. Sprinkling debug calls throughout one composition, as we have done above, can tell you loads of information about your transforms. Dropping state. So this is the big bombshell moment in the entire session for tonight, is now that we are saving state within the button's RX component, we can completely remove the count.
Because the reason why is for each UI element within the observable, it keeps its own internal state. So you don't have an external state. Yeah, because that's one thing.
Awesome.
It is awesome because if you have an external state, you're responsible for it.
Yep, exactly. And other variables could affect it as well. Now this is keeping it just with the button, and you're like tapping it. That's the only thing. You know, you don't have to like check around anywhere. Anyone have any questions? How's this? Is the speed all right? Speed's good.
I'll tell you one thing. It's basically you're talking about. It's not a. You're removing global mutable state with local mutable state.
Yep.
Exactly right.
Yep.
And in fact, that's what functional programming means, to remove as much mutable state as possible.
To remove side effects. Okay, so I'm going to keep going with this one. So dropping state, ding, 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 this is a huge piece. Did you notice what else is different about the above? Before our scan, the subscribe closure looked like this, self.count plus equals 1. After the scan, we remove the self.count. So we've removed our dependency on the count instance variable. In turn, this means we have no stored state in this class anymore. We can now safely remove count from the class entirely. Now Rx is starting to spread its wings. We have removed stored state, and as such, we've removed the potential avenue for bugs. This is awesome. So now we'll actually do that. So we've got the unwrap self.count. We'll remove this increment, and then we can also actually just completely remove this variable, the count. So deleting that building. Oh, we've got an error. So, okay, so all I need to do in here is, so now that we have the count, we actually need to pass it in. So it's going to be...
because you have to scan, which you're already accumulating.
Right,
so you gotta get that value from there. And then
right, so how about in this one, let's hold the scan right here. So let's call it current count.
Yeah, it would help to
now,
the closure, you gotta put the variable. So if you say current count, it should be current count then. Okay.
Yeah. Did you have an update on this one, Jay? Or were you just talking it out?
Just talking it out.
Oh, I'm going to spell that quick.
Count.
Count. So building, Alright. So
Top enough voltage does not.
that is interesting.
Why is that?
I don't know. It's a strange bug to come up. I feel it has to do with this current count right here. Current count. I'm going to put it right here. Because we will be updating it. Since I've done this a bunch of times, I can guarantee that we will be moving this current count from where it
Many
is.
touch, yeah.
Yeah.
Okay.
So this is
I
built
see.
now. We just need to have a named parameter. Okay, so we save that.
Okay, you can't do it in the scan, but you do it in the subscribe.
Right, right.
And maybe that's why, because there's no parameters. You already have a parameter for the scan.
Yeah, I think later on we will be updating this one a bit though.
Yeah.
So we'll get to it. But so just to prove that now we absolutely don't have any stored state in here with the count, let's let it rip.
So it's easy to mess up
Yeah.
the state because
So there we go. No case or no count in there. We tap it. Okay, so we gotta unwrap that one. It's just an optional right here. Or maybe it's not. Next. It's 2 times. Doing that. Current count. Next. Okay, so I need to update this a bit. But let's head back over to here. Current count. I'm gonna go up here. There we go. Current count in the subscribe. That's correct. Prior value. Do we have the prior value here? Yes.
right.
Okay. That looks fine. I'm going to keep going. Okay, so dropping states. We've done that one already. Small improvement. So, small improvement. Though not strictly necessary, let's demonstrate how we can split things out slightly. Sometimes it helps to split a compound operation into multiple individual operations for code clarity. Remember,
Yes.
clever code is hard to maintain code.
Yes.
Truer words were never spoken. In our case, let's leverage map to split out the generation of the messages that's being sent to UI label. So I'm going in here, I see after the scan we've got a map right here. So this is what I meant to do. And this is just kind of saying what we're going to be updating the text to. So after the scan I'm going to copy this into it, jump back into the code, collapse that. After the scan, drop this in the map. Now we have the current count coming in.
Okay, that's where you put
Save
it, and then you put
build
it in the
it.
map. Okay.
Right, and I should be able to remove this current count now.
Yeah.
Oop. I'll undo that. And just keep it as is. Building.
Okay, you need
Yes, so.
it because you're using it in there.
Right, right. So we will be moving this too. So heading back over. So current count's being computed in here now. Now all we need to do is set it up in here. We don't really need to set the text anymore. We'll set text with new text, so we're using the name variable here.
Yeah.
Let me know if I'm going too fast or if you have
No.
any questions. Okay, so inside of here, we're going to be pasting it. So now self.label, I'm going to update it to unwrap self right here. Unwrap self.label.text equals new text. Just updating this parameter in here as well.
Text.
Saving building. And let's see. Text.
Text, yeah.
Looks right. Not current count in. Text. Text. String. Event type. Okay, so I think it's the on next issue that we ran into a bit earlier.
Right. On next. Oh, yeah.
This one. There we go. And just cleaning this up a bit. Building. Okay, so running it. So now we just should have that map creating our current count with the text that we want to return. And we got it. Awesome.
Pretty straightforward.
Yeah.
So basically, you're chaining. What you're doing is chaining.
Mm-hmm.
When you tap, you chain, scan, map, or whatever you need to do, and then dispose.
Right, right. So I'm just looking at the time real quick. I just want to be aware of everyone's time. So it's 6:49 right now. If you have to go at 7, you should give you the heads up of like 11 minutes left. Okay, so any questions before we move on? We're getting really close to the end.
So where is it, like, how's RX storing this?
How is it storing it here? I believe the observable is storing it. It's
Okay.
accumulating the number, so the observable is. But did you want to maybe just look into what RX Swift looks like?
Yeah, I was gonna look at this also after this too because I didn't have a chance to look at the short.
All right, so with just the observer.
Okay.
Basically, this is so similar to Coco's key value observing, and I think that's how React, Objective-C version works by using something like kind of like an implementation of KVO, key value observing.
I don't have much experience doing that, so I'm not sure.
Yeah, similar to that.
But yeah, so because we have the observer with the int type,
Right.
That's what's storing it.
Okay.
Yeah, that's my understanding of it.
So could you access it in different, like outside of the view controller, or is it still just RX? Just like you could.
Right now, the scope on it, because it's all being saved inside of the button, is that the scope of it, if the entire view controller holding the button goes out of scope, then we lose all of it.
Okay.
Yeah.
Which makes sense, right?
Okay, so the small improvement, I believe we've done this already. We've done the map just in here, so I'm going to keep going. So in this more verbose version of our observable chain, it's abundantly clear what is happening. So we should read it out one more time. We're reacting to events on a UI button's tap stream. We're scanning it to reduce it to a single int. Then we're mapping that int and creating a string from it. Then we're subscribing to that observable string type and setting that string to a UI on a UI label. Yes, it's quite a bit longer than the procedural version we started with. That's true. It's a bummer. But in a contrived example like this one, it's to be expected. Most systems use RX are not this simple and have far more wild things going on. Thus, in more complex examples of observable streams, the savings are often considerable. So if you're interested in going a bit deeper and seeing how you can kind of compose observables together, take a look on the Meetup page. I posted a link to a video done at a Ray Wenderlich conference or convention.
Right.
And he goes into depth with all of this stuff. So it's really good watching. And he gives some of the history of these components as well. Okay, so regardless of how long it is, I'd argue that this is actually an extremely approachable block of code.
I agree.
As I said above, it's eminently clear what is happening, because we're just chaining it. It's clear what the input is and how we're mutating it to get to our final subscribe. It's so much easier to reason how this code works since there's no reliance on other functions and no reliance on interface builder wiring. It's true. Since we examined the console output from the scan, let's take a look at how it looks with our newly introduced map. This time, I'll only tap the button once, and I will continue to add new lines for clarity. So after map, he has all those things. So it's basically just the next. We've got the observable with the int, and then now we have the observable with the optional string inside of it. Yeah. Okay, so next steps. The leaves are on 3. We're going to finish up with 4. I don't know if we'll get finished with it, but we'll just keep going until 7 o'clock, and then we'll cut it at that. Next steps. We now have a big win and removed all stored state in our view controller. All right. Next time, we'll take things a little bit further and leverage one of the higher order classes that RxCoco makes available to us, the driver. We'll also clean things up a bit and then take stock of where we've landed. So heading in for 4, our last piece. So we've done all these things. We've learned about Rx Swift. We've converted a simple sample app to use Rx and eliminated stored state. So we've got all this done. We've got rid of a stored state, leveraged a scan function, use map to make it clearer what each step of the process does. Today we're going to introduce the driver object. If you wanted to push the result in an observable chain onto UI elements, such as the string we're generating above that's fraught with peril, what happens if the observable errors? How does the UI element handle that? What happens if the observable is being processed on a background thread? Updating user interface elements from a background thread is a big no-no. Enter the driver. The driver has some interesting attributes to it. The driver is one of the units that is offered in RxCoco. A driver, like all other units, is a special kind of observable. In the case of a driver, it has the following qualities. It never errors, it's always observed on the main thread, and it shares side effects.
That's good because so that you don't put UI stuff on
Yeah,
the background there,
exactly.
which causes
Because it
problems.
just pauses it up.
Right.
So, of those, we're going to focus on the first 2. It fixes both of our problems above. What happens if a driver errors? It can't. What happens if a driver is being processed on a background thread? A driver guarantees it will always be processed on the main thread. Naturally, a driver solves our problem. Furthermore, a driver can drive the value of a UI element. The special trick of the driver allows us to wire a UI control to an observable's output without any manual call to subscribe. So using a driver, to use a driver, we'll go to modify our view controller code a bit. We'll remove the subscribe call entirely and use the driver to drive the UI labels text property instead. First, we have to create a driver. The general way to do this is simply convert an observable to a driver using the observable's asDriver function. Notice the parameter we have to provide to asDriver. If we do the conversion right after the scan, immediately we hit something unexpected. We have to provide an int in order to create the driver. The reason why is clear from the parameter name, on error just return. To convert an observable to a driver, we need to provide a value to use in case the source observable errors. In our case, we'll just use 0. So here's our new chain. So I'm just going to copy this. We've got the asDriver. It's the only one that we're adding in, and then we're going to be moving down a bit. So just asDriver and the after scan before the map. So after scan, after the map. So right here, asDriver. So building it.
And you can just, basically, you can pretty much chain these things. That's the beautiful part.
Right. So this one, I have this code already. I'm just going to grab it since we're kind of running out of time. So asDriver on error just return. Copy this one. Looks like what it says. Let's make sure. Not sure where we have an error. Oh, is it before the map? Yes, it's before the map. So I use the keyboard shortcut, Command Option, left bracket to move it up. There we go.
Okay. Oh, it has.
Sure.
And with this, then you can get rid of the subscribe.
Yep. Pasting it in. Build it. Alright, here we go.
Okay, I see. So if you use asDriver, you don't have to.
Don't use subscribe.
Because the thing is, you already automatically subscribe
On the main thread as well.
on the main thread.
Yep.
Okay, so then.
Alright, so we're going to just run it. I'm building it and running it now, just to make sure it's working as a driver now. Alright, that's perfect timing. There we go.
Yeah.
So it's working. Head back over and just close this one out. So we removed our call to subscribe and are simply asking the driver to push updates on the UI label's RX text property. We still need to add this to a dispose bag. We've already done that.
Yeah.
So I'm just going to go all the way down and clean up. Now that we know everything is working as intended, let's get rid of our calls to debug, and here's the final RXified version of View Controller. So look how tiny that is. So I'll just finish it up by removing these, and then we will be done. So this stuff I'm just going to, this is all just extra stuff next time. So just cleaning up the debug, and then that'll be the end of the meetup, the formal meetup. So removing this with a triple click, and that's it. So we've got that, we're running it. No shared state, completely using RX Swift observables. There we go. Alright, so that was a meetup. Thanks for coming, guys. I'm going to shut down the stream, and then we can just kind of sit around and talk for a bit if you guys want.
Cool.
Take orders. Okay, just bringing it up. Yes, stop with the stream.